is the new and new project of Jang and Jang. We are testing whether or not phone cases will increase the coefficient of friction of your phone. First, we have a small phone case. The small phone case weighs about 4 grams. Then, we have a large phone case, which weighs about 5 grams. But this larger phone case has a larger surface area. And finally, we have the phone, which weighs about 70 grams. First, we are going to find the force it takes to pull the phone without any cases. Next, we are going to find the force it takes to pull the phone with a lighter phone case. Finally, we are going to find the force it takes to pull the phone with a larger case.
The purpose of this experiment is finding the coefficient of friction of a phone with and without its cover. Our hypothesis is a phone with its cover will be significantly bigger than a phone without its cover, and we're talking about its coefficient of friction. For our materials, we used a phone and multiple covers, and our handmade spring scale to measure masses and forces. For this experiment, we're going to assume that the ground is level, we're pulling the phone with a constant force, and there wasn't a significant amount of debris on the ground to affect the friction. Since we kept applying force to the phone until it just began to move, we can assume that F application equals F frict. And with our known equations, we can say that F frict equals mu times F norm.
This is our list of masses. The first one is the small case with the phone, the big case with the phone, and the phone itself. For the force of application, the small case took 1.225 newtons, and the big case took 1.568 newtons. For force normal, our small case was 0.726 newtons, and the big case was 0.734 newtons.
Using our equations, we can solve for mu by setting mu equal to F frict divided by Fn. Divide both sides by Fn. We plug in our values, and F frict is 1.225 newtons for the small phone case. Fn for that same phone case is 0.726 newtons. We solve and we get 1.68 as our mu. For the larger phone case, we do the same thing. F frict for the larger phone case is 1.568 newtons, and Fn equals 0.734 newtons. When we solve, we get 2.14.
To find the mu of the phone itself, we first list our variables. Mass is 70.1 grams, normal force is 0.69 newtons, force of friction is 0.98 newtons. Mu equals F friction over normal force, which equals 0.98 newtons over 0.69 newtons, which ends up as 1.42. For finding the uncertainty, we first found the small uncertainty, which the equation was the uncertainty of mu equals mu times in parentheses uncertainty of friction, force of friction over force of friction, plus uncertainty of normal force over normal force. After plugging everything in, we got 0.001, which was the uncertainty of mu for the small one. For the large one, we used the same equation, and after plugging everything in, we got 0.002 as the uncertainty. For the phone itself, we used the same equation yet again, and after plugging everything in, we got 0.018 as the uncertainty of mu.
Well, as you can see in this graph, as the mass increases and F norm increases, the force of friction increases dramatically. For example, the mass increases from 74.1 grams to 75.1 grams right here. But as you can see, force of friction increases dramatically from 1.225 to 1.568 in the graph. In reality, that's not a lot. But the coefficient of friction increases from 1.68 to 2.14, which is a lot.
In our lab, the larger phone case had a larger mu than the smaller phone case, and this is probably because the larger phone case had a larger surface area. In our lab we had some uncertainties, and this was because we had uncertainties on our spring scale and the electronical scale we used to confirm our masses.
The purpose of this lab was we were trying to find out if phone covers were really effective in providing good grip to its users. In the end, we found out that phone covers really are effective. Without the phone cover, the coefficient of friction for the phone without the cover was 1.42. With the phone cover, the number rose to 1.68, and then the larger the phone and the larger the cover, it went up to 2.14. That is a big difference. In the end, phone covers really are effective.